Here I'm going to tell how to align the telescope by daylight. Of course, it can also be used during night. What's needed is an app or another source of ephemeris data, and a level and a wedge of which the angle is equal to the geographical latitude of your location, and of course a telescope which is equatorial mounted. Okay, here the first thing to be done is that the telescope tube should be exactly level plus the geographical latitude of your location. This example, it's a latitude is 25 degrees south. So as you see now, it's not in level. So I have to adjust this with this super Polaris mount with these adjustment screws, and this should be lowered until this is level. As you see now, it's perfectly level. The next step to be done is rotate the telescope in 90 degrees, and then rotate the declination axis until the telescope is level again. This is not exactly level. Now rotate the declination axis until this is level again. Level, of course, with taking into account the geographical latitude, 25 degrees in this example. Next step is that this adjustment ring should be exactly to 90 degrees, because it should point to the celestial pole. In this case, the South Pole, but in the Northern Hemisphere, the procedure is exactly the same. Now rotate the telescope until the declination axis is equal to your latitude, in this case 25 degrees south, and then in this direction the telescope should be exactly level, and yes, it is, so this is correct. And now I have to adjust the RA axis until the other side is also level. Okay, that's finished. You can also do it by this way, holding it against the telescope tube on both sides, which should also be exactly the same value. And the next step is setting the correct right ascension of the zenith. The sidereal time is 1:48, local sidereal time, so this RA axis should be set to 1:48, but unfortunately these rings are designed for the Northern Hemisphere, so I have to set them to 24 minus 1:48, so that is 22:12. Okay, now it should be pointed at the zenith. Next step can be a dangerous step during daytime, but a warning, because I have to point the telescope at the sun. But fortunately, as you see here, the sun is a little bit in the trees, so it's a little bit attenuated by the trees. But normally you can, when there is moon or Venus, or at night time, of course, normal stars, use a normal star or another object. So now I use the sun. The RA is 2103 and the DE is minus 16.6. Now I have to point the telescope at the sun according to the setting circles. Okay, it's set to declination minus 16.6, and minus 16.6 should be exactly 2, and RA to 2102. So that's actually 258 and 259. So it's actually 2102. Now it should be okay. Now use these adjustment knobs to set the horizontal position of the equatorial mount, and then check whether the sun is in the field. This is a dangerous operation when you use the sun. preferably use the moon or Venus, but it's currently not in the sky. As you see here now, you see the sun is indeed in the field, but never, and really never, look to in this case through the iPad, or you will be blinded forever. Okay, now I'm going to look up a star, Ashenar, and it's 128 minus 57.2. So here now I set it up here. I set it up to 128 on the RA axis, on the DE axis, on the DE axis 57.2. So this is Ashenar, and now we have a look through the eyepiece. Now check whether the star